Hi there. Whenever we're doing machine learning, it's sometimes difficult to understand what's going on. There's a lot of complicated math, and it would be really nice to get like a visual kind of understanding or intuition behind what's going on. Math is complicated, and some of these models get super duper complicated. Any decent neural network is going to have billions of parameters, if not trillions. That's too much to really hone our intuition on. To get an intuition for what's going on, we're going to need to work with very simple models, stuff that we can visualize. And if we can grasp what's going on there, it'll kind of help illuminate what's going on with more complicated models. So we're going to work with a very simple Perceptron classifier. And the very first thing we're going to have to do is graph our data. And then we're going to have to see, is there a line that kind of splits the data into positive examples and negative examples, or let's say ones and zeros, or ones and negative ones, or something like that. So let me pull up some graphing software and let's look at our data. So here we've got a made-up data set. It just consists of 8 points, and they're split up into ones and zeros. So we've got a binary classification type thing going on, and we've got 2 features or 2 input variables. We have x1 and x2. I guess our first question is, how do we graph these points? Because you can see from this graph on the right that it's 2-dimensional. Well, so how do you graph 2 dimensions in 3 dimensions? We're going to have to get a little bit abstract. Essentially, we're going to designate one of these axes as x1, the other one as x2, plot these pairs just like you would with in high school, and then we'll either plot ones and zeros to designate their value, or color code them, or zeros and ones, or maybe hollow circles and dark circles. We'll do color coding, and here I've actually already kind of hinted at the colors. We've got purple and red. As I mentioned, it is completely arbitrary which we call x1 and which one we call x2. And the reason for that, I think, should be obvious. These are both inputs, so they're equally relevant. Normally in high school you have, y is reserved for your output, but here y is going to be a color. So they're both inputs, and it's arbitrary which one we list first. Essentially, we could take our graph and just rotate it, and then what was horizontal became vertical, and it's still the same information. If we were trying to figure out if this was this is maybe a dating app, and you wanted to know if a person was someone you wanted to date, and that if there were ones, they were dateable, and if there were zeros, and not so dateable, then maybe x1 is whether they're cute, and x2 is whether they're smart. And there's nothing about cuteness that requires it to go on the horizontal axis and not the vertical axis. It's completely up to you. So pick one and stick with it. Or maybe your professor has a preference and they'll tell you on an assignment. So we're going to have x1 be our horizontal and x2 be our vertical, but then we'll rotate our graph and you'll see that it doesn't matter. So let's plot these points. I've got this right here, and you can see that we've got our points plotted, and the quote-unquote y-axis is actually just a color, so whether they're dateable or not, or whether they're purple or red, ones and zeros. That's pretty straightforward, I think. And the question for us then is, what would be a good classifier to help us split up these points into their 2 different categories? Now, as I said, we want to keep things really nice and simple, so we'll work with a Perceptron model. If you need an update on the Perceptron, I've got some other videos on that. But for right now, let's just do a quick 30-second, 1-minute summary of what the Perceptron is. So let me bring up my whiteboard. The simplest perceptron model is a single neuron with a binary output. So it takes inputs and it gives you outputs. We'll just denote our inputs. We'll just have two of them. Again, just to keep things simple, we have x1 and x2. And these get weighted. So in other words, whether a person is cute or whether a person is intelligent, you have your preferences, your dating preferences over which you value more. And so that you have your weights that are attached to that. It's also traditional to have a bias as well, just a strictly additive term. And what we do is we take this weighted sum of these three items, so we sum them up, and then we feed these through an activation function, and that gives us either a 0 or a 1. That gives us our output. So here's the idea. We're going to take x1 and weight it by w1. We'll take x2 and weight it by w2. We'll add on a bias, and we'll call this thing, let's say, z. The way the perceptron works is it has a stepwise activation function. What that means is if z is bigger than or equal to 0, so if this weighted sum, this linear combination of inputs, if that thing is bigger than 0, then our prediction, let's call that y hat, is a 1. And if z is less than 0, then we're going to predict a 0 or a -1 or, dateable, not dateable, or some other binary classification. Okay, so that's the perceptron model, and we work through data, and we're constantly going to be updating our weights and biases until we achieve a perfect separation between our points. And our challenge for today's video is to try to graph what that separation is like. We'll get the graphing software to do it first, and then we'll actually work out the math behind what that equation is. Okay, so we've plotted our points, and then we randomly guess an initial set of weights and biases and try them out. And if by some miracle they correctly classify our points, then we're done. If not, we got to apply some kind of learning rule, maybe the perceptron update rule, to try to get a set of weights and biases that perfectly classifies our points. What you can see from this picture is that this classifier is absolutely horrible. I have these 3 purple points in the red area. They're completely misclassified. Here I have 1 correctly classified purple point. All of my red points have been misclassified as purple. So we would have to apply some kind of learning rule. And eventually, hopefully, we get something good. So we can try something like, we can change the slope, the weight on the first. Maybe we can change the weight on the second one. Maybe a bias as well. And hey, well, actually, this one works. This one works great. Now I've got all of my purple points in the purple region, all of my red points in the red region. We now have a perfectly serviceable classifier with 3 parameters. The first weight, the weight on x1, I think that was whether you're cute, was a -3. So I guess we don't care if you're cute. Maybe we dislike cute people when we're dating. W2 is whether you're smart, or the weight attached to whether you're smart. We like that. And then we've got some kind of threshold, some standard for everything that's a -6, whatever that means. So what is the equation of this line that splits the purples from the reds? I see my weights and biases, but this is a straight line that separates these two. What is the equation of that straight line? Well, now we need to do a little bit of high school algebra. So let's pull up our whiteboard and we'll work it out. It's not too hard. Okay, so we had x1 here, we had x2 there, and there was some kind of line that split up our points into positives and negatives. So what is the equation of that line? Right, well, the thing to remember is this is our perceptron model, this set of equations. But whether we classify someone as dateable or not strictly depends on the value of this z function and whether it is positive or negative. So 0 is this line of demarcation between dateable and non-dateable. 0 specifically on z. So if I want to know what this line is that splits up between those two classifications, let's set z equal to 0, because that's the line that splits up into dateable and non-dateable. So let's take this equation and we'll substitute a 0 for z. And then we have w1x1, w2x2, and the bias. Now, if I remember properly from my previous screen, w1 was a -3. So we're going to put that in there. w2 was a 1. So I can multiply by 1 or ignore that because it's just multiplying by 1. And then our bias was -6. Okay, now this doesn't quite look like a straight line yet, but we're getting there. All right, now we have x2s and x1s. For a second, I just want you to forget that and just remember high school when you were plotting y's and x's. And if I asked you what the equation of a straight line was, you would have said y is mx plus b. The idea is that we have some line, and I want to isolate whatever variable is on my vertical axis. And here it was y, but for our real problem, it's x2. All right, so what I want to do then is express this equation here, treating my x2 as y. I want to have it all by itself on the left-hand side of the equal sign, and then everything else on the right. Okay, so I can do that. Again, I just want to have x2 by itself, everything else on the other side. So if I add 6 to both sides, I get this, right, by adding 6 to both sides. If I add 3x plus 1 to both sides, this guy goes over there. And then if I just swap what's on the left with what's on the right, I get x2 is equal to 3x1 plus 6. Which, gosh, if this doesn't look like mx plus b. Right? Except, again, I don't have y's anymore. I have x2s and x1s. But this is the equation of a straight line. And so you should know how to graph a straight line. You just plug in values for x, you get out your y, you plot those points, and then you connect them with a straight line. So let's do that real quick then. All right, so I'm going to feed in x1. I want to get out my y variable, x2. The easiest point to plug in is 0 for x1. So if I plug in a 0, then this part vanishes, leaving me with just x2 is equal to 6. And let's plug in, let's say a 1. If I plug in a 1 for x1, then I have 3 times 1, which is just 3, plus 6 gives us 9. All right, so when x1 is 0, x2 is 6, so this point right here. And when x1 is 1, x2 is 9, and I connect those with a straight line and a ruler, and I have the equation of I've graphed by hand the line that should be equal to what we had in our earlier graphing software, namely this. So the equation of the line that splits purple from red is x2 is equal to 3x1 plus 6. That's it. We're done.